Okay, so today I'm going to be talking about glaciated highland erosion landforms. So these are just landforms that occur in highlands, occur in mountains, these kind of areas, and that have been formed by erosion, as the title sort of indicates. Okay, now these can be sorted into macro landforms, meso landforms, and micro landforms. Now, macro is just a big landform, meso is a medium, and micro is a small. So these are just the categories that you can put them in. Okay, and the first one we're going to start with is a cirque or a corrie. They're they're the same thing. They're just two different names. Okay, cirque slash corrie. Okay, and what we have here is we have a mountain, and in this mountain we have a sort of little bit of a hollow, right? Okay, and basically what happens in this hollow is over thousands, hundreds of thousands of years, snow starts to form here. Okay, and as this snow, or well, snow, right, like compacts here, okay, from clouds and from obviously weather, and as this snow starts to survive through winters and summers, so as global average temperature drops, so in usually in glacial periods of time, right, that the snow is able to survive year round, and therefore it can start to compact more and more. And when the snow compacts more and more, it goes from snow, right? It goes to snow to fern. Another word for fern is neve. And this kind of slightly erodes, but not really, the landscape underneath. And this is why you have a formation called a nivation hollow. So nivation hollow, and this is basically the nivation hollow, and the nivation hollow starts to build up into a cirque slash corrie when snow compacts and accumulates even more. And when the snow accumulates even more, what you're left with, let's just redo this, is you're left with your slope, and let's read that. You're left with your slope and glacial ice, okay? And this glacial ice begins to expand and accumulate as over millions of years or hundreds of thousands of years, very long period of time, okay? And a glacier forms. And when this glacier, gets big enough, it starts to pluck at the back wall as gravity pulls down on it, down further down slope. It starts to drag this part of the glacier downhill and pluck this part of the glacier plucks at the back wall because the glacial ice has been attached to the back wall for so long that when it finally starts to move, the rock literally just comes out with it. So what you end up with is you end up with a really, really, really steep back wall, like so. And you'll also end up with a bunch of rocks within the glacier, and maybe you'll have, some gaps like this because of the rocks being plucked out. But in general, you end up with a really steep back wall. And furthermore, down here, you have abrasion. And what abrasion is it's literally just rocks, maybe, that came from this plucking or came from frost thaw further up. Sorry, freeze thaw slash frost shattering further up. You have the rocks here, and they abrade this surface. So first they form striations through abrasion, and then they literally just deepen this hollow because they've scraped across the ground so much they just deepen this hollow, and you end up with a massive hollow, really deep, and a rock lip here, which is just the raised bit before the gradient goes down. Okay, and eventually, after a glacial period, so during an interglacial period when temperatures have warmed, you are left with this, and this is a corrie. It's just a mountain with a really steep back wall and a hollow. Okay, and this corrie sometimes fills with water, and we call this a tarn. It's a really forgettable name, but I'll type it out. Okay, so we call this a tarn, and this tarn is in a corrie. Okay, and that is the formation of a corrie. Now next we're going to go for an arete, and since you now know the formation of a corrie, the formation of an arete is a lot easier. So we're not actually going to rub this out because the arete sort of carries on from a corrie. So once you have your back wall here, right, imagine you have this corrie, but it's on the other side as well. So now you have that was a bit messed up. Now you have your corrie, but it's on the other side, okay? And so now you have a ridge that's going along both these corries on two sides. So an arete is when there's two corries. It can't be more than that. It can't be less. Two corries, you have an arete. Now, if we look at this from the side, so from the side profile, you could see that the arete is literally just a ridge, right? That's going up. And actually, if we go back to here, what I failed to mention is that let's go forwards. Is that when the glacier is actually in the corrie, so when the glacier is actually here, there we are, it steepens the arete. It makes the arete thinner. Now this is going to be hard to sort of draw, but if we have the arete, let's assume let's get this glacier. Let's just go like that. So let's fill in this glacier. So this is your glacier from the side, right? Let's assume there's a wall to the side of this glacier, and that wall is your that wall is gonna be your, what do you call it? Arete. So that's gonna be your ridge. And what happens is this glacier here undergoes rotational slip when it gets really heavy, so it just starts kind of rotating inside of this depression. It starts, and when it does that, it's hard to imagine, but you just have to know that it basically thins this what do you call it, this arete. It thins it because the glacier is eroding. It thins this arete, and you get a really thin kind of ridge. Now this ridge, obviously, as I've mentioned before, just travels upwards to the peak, and what you're left with is this is, let's say this is your arete, right? You're left with a peak and an arete on the other side. However, your new formation, so let me actually type out arete so you know how it's spelled, so you know that this is your arete. Your new formation is now a pyramidal peak. Now this, I might be going too far ahead of this, but your pyramidal peak is super simple. It's not really much to remember. It's literally just when you have an arete, or when you have two corries. It's literally when you have three or more corries. So if you're looking at it from a top profile, you have a corrie here, and a corrie here, and you just end up with a pyramidal peak. So if you know what the Matterhorn looks like, it looks something like this, right? It literally just looks like a pyramid. And that's because you have an arete here, and arete on the other side, behind this, okay? And that is literally what a pyramidal peak is. It's just three aretes that make, it's three corries that make three aretes. This ridge is the arete, right? And now there's now three aretes leading up to the middle, and that's a pyramidal peak. And that is another glaciated highland landform, erosion landform, okay? And those are your cirques, aretes, pyramidal peaks, and yeah, there you are. Okay, and corries. But that is a cirque. Okay, so next we have a trough, which is basically just a U-shaped valley. Now this one's super quick to explain, so I'm literally just going to draw a U-shaped valley, or a V-shaped valley. So you have your V-shaped valley. This is actually also known as a U-shaped valley, just so you know. So if you don't know how a V-shaped valley is formed, all you need to mention, even if you do know how it's formed, is that it was formed by a river. Okay, formed by a river. Now, when a glacier starts to push through, when a glacier starts to form, when global average temperatures get colder, you have the glacier traveling through this V-shaped valley. So let's just fill that in. You have the glacier here, right? Now, as we've already mentioned with a bunch of the erosional processes, this glacier erodes actually, the main way it actually becomes a U-shaped valley is through abrasion. So abrasion actually occurs on the side walls as well as the bottom of the glacier, and eventually this glacier abrades the sides and the bottom, and it just becomes a U-shaped valley. So now you can see that the glacier is like this, right? It's super simple. It just abrades the side walls. Let's use this. Abrades the side walls, creates striations, removes rock from the side walls and from the base, and now I just have rocks in the glacier. So now you can imagine the glacier is just traveling downhill, and it has rocks in it because it's abraded the side and the bottom of the glacier, of the V-shaped valley. And that is literally what a trough or a U-shaped valley is. You only need to remember one of the terms, you don't need to remember both, but, you know, just in case, right? And now we're going to talk about a truncated spur. So truncated spur, here we have truncated spur. If you don't know what a, what's it called? If you don't know what a, crap. So truncated spur is basically where you have your regular interlocking spurs. There we are, interlocking spurs, which are literally just, if you can imagine each of these lines is like a mountain. So let's just go like that. Each of these lines is like a mountain, and a river long ago has eroded its way through the mountain and around the kind of fastest route it can take. And the fastest route that it can take just ends up to be winding and down through mountains, sort of in a truncated spur position. So that's harder to sorry, in an interlocking spur sort of landform. So that's kind of harder for me to explain, but I'll make a video for it on my channel if you want to go and see that. I'll make it extended. But what a truncated spur is you literally have your interlocking spurs. So you have like this, and you have like this, and you have like this, for example. And let's assume this is your mountain up here. So this is like the highlands, and let's go ahead and make it pretty. Let's say this is like the grass flatlands over here, and you know, you have your mountain up there, and you have your low sort of areas here. Now, all the glacier does, right, is it's kind of like the river. It wants to come downhill, right? It wants to advance. So you have your glacier here, and it wants to come down here. But the problem is, your glacial ice can't move around the protruding kind of air rocks, right? Because it's not, the river hasn't really eroded a straight path through the mountains. So the problem is it can't travel through it. It can't travel around it, because the glacier just doesn't deform as well as water does it? It just can't move around this land as well as water can, because it's not as fluid as water. So what ends up happening is you literally just end up having your truncated, your interlocking spurs, right? You end up having your interlocking spurs, and they curve down and down and down, and instead of going like this, right, they just go like this, because what's happened is the glacier has literally just cut through the interlocking spurs. It's going downhill. It's coming our way still towards the grassland down here, right? But it's just cut through the interlocking spurs because it doesn't have the flexibility to go around the rocks. It just erodes straight through them, and now all you have is a straight flowing glacier. Okay, and when the glacier melts, all you're left with is just a landform that kind of looks like this. It looks weird because, well, it should be interlocking spurs. It should be like hills, right? Mountains, but it's not. It's just straight cut, and that's just through sheer force from the glacier. And that is literally just what a truncated spur is, okay? Next, hanging valley. Okay, so all the ones we've covered so far, I've forgot to tell you, but they're all macro. I'll write it at the end. They're all macro. But next, we're going to go through a hanging valley. Now, hanging valley, what is it? Well, if you think about it, if you have a landscape, you have your U-shaped valley. Or actually, let's look at this from a topographical perspective. You have your main valley down here, right? Formed by rivers a long time ago, and you might have tributary areas. So tributary rivers that have kind of combined. They've kind of uh, met with your regular valley. So this is kind of like the water basin, right? You have your water basin, and you have your rivers. Let's kind of make this look a bit better so you can understand. You have your rivers going down here, your smaller rivers meeting up with the bigger river, and basically what happens when a glacier appears, when it gets really cold and a glacier appears, is you have your glaciers, but the problem is, let's just cut this off, right? Let's cut this off a little bit so I can fit it. You have your glaciers, and so you have your main one in the middle here, right? And you have your side ones here. Now, the thing is, these side ones, as you can imagine, are much smaller than the bigger one in the middle. So the bigger one is going to be abrading the bottom. It's going to be abrading the bottom. So let's have your glacier here. Let's imagine this is the main valley, and let's imagine this is the smaller valleys, right? Your bigger one is going to be abrading a lot faster. Braiding the sides and the bottom a lot faster than the smaller one is. So what you'll end up with over time is you'll end up with a really deep main valley, because it's just got so much more erosional power. You'll end up with a really deep main valley like that and have really steep walls. But with this one, it's not really going to erode that much. It might get a little bit wider and a little bit deeper, but it's not going to erode that much. And so when you look at a valley, let's say this is the main valley from a side perspective, you can see that the this is quite difficult to do actually. You can see that the main kind of valley, let's assume this is the main valley, and let's just draw a little river, just to a little river going from upstream downstream, so going this way. And then you have your little rivers here. So what you can see is that because the main valley has eroded much deeper and much wider than the smaller valleys, what you see is the smaller valleys are left hanging up here. So I'm not sure if this is a good depiction, but from my perspective, it kind of makes sense. So you have your hanging valley up here, right? And these are your smaller valleys, but these are your hanging valleys, and waterfalls. As the glacier melts, waterfalls eventually occur because a river kind of comes down this area, right? I'm going to try and make this a little bit better, a little bit more 3D. I'm not the best drawer, but here you are. You can kind of see that this is the main valley going through down here, and this is your rivers going down this way. And they form waterfalls, which is your hanging valleys. Bit harder to explain or draw this one, but hopefully it makes sense. And that one's also a macro erosional landform, because if you think about it, it's super big relative to what like a glacier can erode, right? A glacier is one of the biggest things that landforms a glacier can erode. Now we're going to lead into we're going to go into micro straight away, right? And we've already mentioned this a bunch of times. I'm not sure about if you remember it, but basically when a glacier is moving over a bit of rock, let's get a blue glacier please. When a glacier is moving over a bit of rock and it's got stones within it, it abrades this rock and it just creates striations as the stones kind of drag along. It just creates long kind of lines in the rock like that. They're just called striations. Let me type that out for you. Striations. That's literally what they are. You can search them up. You'll get a pretty good idea of what they are if you don't understand now. And that's a micro erosional landform. It literally is classified as a landform. Okay, and then there's one meso one, which is obviously not as big because it's meso, but it's kind of complicated. So we're going to go for it. It's called a roche moutonnee. which is spelt like this, I believe. Okay. And all you have with your roche moutonnee is you have a sort of glacier that's traveling along a piece of land that's getting ever so steep, maybe, and then you have a drop. Okay, and the glacier is traveling along this, like so. And along this side, this is called the stoss side. Along this side, you are going to get a bunch of striations and abrasion, as I've already mentioned. Along here, let's do that in a bit of grey. You're going to get a bunch of striations along here because there's just a bunch of rocks and pressure is kind of building up as the glacier is moving to get along this kind of upward gradient. And as soon as the glacier reaches the other side, you'll actually see, as I've already talked about in a recent video, laminar flow, you'll actually see crevasses start to form in the glacier as it moves down this area. So I believe this is it compressional laminar flow? No, it's extending flow. It's extending laminar flow, and it's literally just when there's crevasses because the ice moves really fast as it goes downhill, and then you just get your glacier back here. And what it does is it literally just plucks this side, which is called the lee side. It plucks the back wall here, and what you end up with when the glacier has fully melted is you end up just with a formation like that, okay, where there is, or actually let's go like that, and that is literally just your roche moutonnee. It's got striations on the stoss side, and on the lee side it's just got some rocks here and, you know, a bit of a really steep wall that's kind of been plucked at, and that is literally your roche moutonnee. Okay, and these are all your glacial highland erosion landforms. And so the first ones that I mentioned were all macro, and then the striations that I just mentioned was micro, and the roche moutonnee was meso. And that's literally just all your landforms.